So how does this apply to what we've been talking about with trig? Well, here's my sine graph. Okay, here's the parent function of sine. I drew it beforehand, so if you want to take a few seconds to draw one on your own. And what I ended up doing was graphing the inverse of that too. So I replaced my x's with my y's and my y's with my x's. So these x values ended up becoming my y values. So pi over 2, pi, 3 pi over 2, and 2 pi. My 1 and negative 1 ended up switching this way. So be careful when you're drawing this because you end up switching to negative 1 and 1. Most people mess that up. Now the problem is that sine is not considered 101 because there's a repetition of y values. 0, pi, 2 pi all have repeating y's 0. So this relation here is not a function. So again, the original function is a function, but this is not what we call one-to-one. Okay, this is not 101, so therefore this is not a function. Well, what we're going to be talking about today are inverses of our trig functions. And there's only one answer that ends up happening when we're doing these inverse functions. So graphically, what we want to be able to see is when do I have one continuous piece of the graph that has every single answer that sine will provide? Well, if I start here at 0, I can go this way to 1 comma pi over 2 and have all the answers here and start repeating all those answers again here. So like if you have root 3 over 2, root 3 over 2 is over here. 1/2, there's repeated answers. So I'm only going to deal with this half here that goes from 0, 0 to 1 to pi over 2. Well, I could get different negative answers over here, but I need to have one continuous graph, which is why I drew my graph to negative pi over 2. If I start here at negative pi over 2 and negative 1, or negative 1, negative pi over 2, I have a continuous graph going all the way for this sine function from negative pi over 2 to pi over 2, or negative 1 to 1. None of my answers end up being repeated, but I have all the answers for any ratio that I plug into inverse sine. So if I honestly would have graphed the negative pi over 2 here, I would have been able to talk about where the function for sine is 1-to-1. From negative pi over 2 to pi over 2 is when my function is 1-to-1. Therefore, the inverse could be a function. But if we talk about the infinite graph for sine, it's not 101, so the inverse is not a function. So again, the idea here is to get an inverse that is a function. So we only go from negative 1-to-1, which outputs negative pi over 2 to pi over 2. So the same thing kind of happens when we talk about the graph for cosine. Again, this cosine graph goes on forever, so this is not 1-to-1. Therefore, the function, or the relation, is not a function. The one that goes on forever does not. So what we want to do is we want to look at the relation and try to figure out when could I have all the answers that are continuous and not repeating. So if I start like what I did with sine, I'm going to start here at 0. So with cosine, we start off with the 0.10. I could go to negative pi over 2 or negative pi this way, but that part of my function or my inverse is not 1-to-1. So that's going to be not a function. So I'm going to start here and actually go in the positive direction and end when I have no repetition of answers. If I continued going from here, I would end up repeating those same negative answers. So for cosine, we actually talk about it going from 0 to pi. Not negative pi over 2 to pi over 2 like what we did with sine inverse, but from 0 to pi. What about tangent? Tangent, same idea. If we're talking about the function that repeats forever, all of these just keep going over and over again. And if we flip everything over, we end up getting these graphs where this inverse is not a function. So we need to take one continuous piece of the graph in order to make it one function. Well, I could talk about pi over 2 to pi, or 3 pi over 2, but there's no point of going that way. We want to kind of stick it with something that also had the same range of answers. Well, negative pi over 2 to pi over 2 matches exactly with the range of answers that sine does. So what we're trying to get you to do here is just to kind of visualize what inverses are doing and how we can get it to be a function where the original function is 1 to 1, and so then the inverse is also 1 to 1. So looking at this piece of the cosine graph lets us have a function for our inverse cosine. This part here has all the different answers for tangent that go on forever left to right, but end up having like two horizontal asymptotes, one at pi over 2 and one at negative pi over 2. Okay, so this is just an illustration of what we are talking about with inverse trig functions.